today in class we talked about transformations. So what we're doing is we're starting off easy. Transformations are like that moving the monster stuff we did, where we shifted things up or shifted them down, we moved them and stretched them and compressed them. We're going to start out easy with these transformations. So we're starting with quadratics. Okay, so if I look at this function right here, okay, the easiest thing for me to locate, well, first of all, I can tell, does it have a minimum or a maximum? Well, right here, I can see that my parabola doesn't go any lower than that line there. So it does have a minimum, and the value of that minimum is -5. So if they ask me what the minimum was, boom, it's right there at -5 because that is the lowest y value that I have. Okay, I can also find the vertex, which is right here at 0, -5. Now we can tell that by looking at the equation, but we're not going to talk about that just yet. We will get there. Okay, so we talked about domain and range. Now domain of a quadratic function is not limited because, now again, as we've always talked about, if we have a situation that is going to put limitations on that's going to put limitations. So this is talking about functions. All I have right here is a function or an equation. There's no limitations put on that, so my domain is going to be all real numbers. Okay? From my vertex, I can find my axis of symmetry and my range. Because remember, my vertex, we talked about this yesterday, my vertex is h, k. For range, I have y is greater than or equal to or less than or equal to k. My axis of symmetry is x equals h. Well, this is h, k. So I have axis of symmetry is x equals 0, and my range is y, and I've got a -5. I can tell whether it's greater than. If it's pointing up, it's greater than or equal to. If it's pointing down, it's less than or equal to. So in this case, because we're pointing up, that means all the values that I have got to be bigger than -7. Okay? Now, so that's just a simple, straightforward function. Now, we're going to look at this one. Now, what this one does is it says g of x is f of x plus 7. Okay? So I basically have a little system here. Okay? I've got f of x here, and I've got f of x here. So I can substitute that in for f of x. So my new function is g of x equals 3x squared minus 5 plus 7, because that was my original function. Okay? So basically what that says, again, like, not to get too mathy on you, but what it's saying is this function, g of x, which is just another function. It's not like y'all flip out when you see function notation, f of x, g of x, but all it is just another function. This one's called g of x, that one's called f of x, okay? They're both the output part of their function. So for this function, the output of this function is f of x. For this one, the output is g of x. Okay, so if we take that and we put it in our calculator, we go to y equals, okay, and we put, just so that we can see what's happening, let's put the original 3x squared minus 5 in y1, and let's put the new one, 3x squared minus 5 plus 7 in the new one. Now, I have the color calculator, so it's pretty easy for me to be able to see what the different lines are, but on the old calculators, the calculators that we use on tests, if you need to, you can arrow over like this and hit enter and make the line fat. That way you'll be able to tell the difference between the old and the new. On my calculator, the old is going to be a blue line, and the new one's going to be a red line. Any second now, red line. There it is, okay? So this is my old function, my original function, and this is my new one. So if we look closely, we can see that this one shifted up 1, 2, 3, 4, 5, 6, 7. So this shifted up, well, 7 units up, okay? Now, so if I look here, what's shifting up is my vertex, okay? So my vertex was here, and it's going to shift up. Shifting up my vertex causes everything else in the parabola to shift as well, okay? So if I take this vertex and I shift it up 1, 2, 3, 4, 5, 6, 7, My new vertex is at 0, 2. Okay? So this doesn't change my axis of symmetry because it didn't go side to side. It just shifted up. So my axis of symmetry is still x equals 0, which I can also tell by looking at my vertex. But my range changed because now, instead of the bottom, the smallest value I have being -5, the smallest value I have is +2, which I can also tell from looking at my vertex. And unless I have a situation to limit me, my domain is still going to be all real numbers. Okay? Now, for this last one, based on what we saw happen here, okay, here we saw that when I added 7, it shifted 7 units up. Here I see when I subtract 2, what do you think is going to happen? Well, I think what's going to happen is I'm going to go 2 units down. So let's look at our calculator and let's see if that's actually what happens. So I'm just going to change this because, again, if I take h of x, it's f of x, which is still 3x squared minus 5. Okay, so I'm still going to take my original and substitute it in. It's 3x squared minus 5 minus 2. Okay, so we're going to see what that does. So let's put that in our calculator. So I'm just going to change this. Oh my goodness, what just happened? I'm just going to change this to -2, and then let's look. Okay, so there's my original, my blue one, and there's my new one, and it is shifted down too, just like we thought it would. So my vertex shifted down 2, which puts it at 0, -7. Now again, I'm looking at the graph, but you can look at the table and see all the same stuff happening, okay? I see my vertex, see it's surrounded by symmetrical pairs. I see my new vertex also surrounded by symmetrical pairs. It was 0, -5, now it's 0, -7. All the same information I'm getting off the graph, I can get out of the calculator, out of the table as well. Okay? So based on my vertex, my axis of symmetry is x equals 0. My range is y is greater than or equal to -7. Okay? And my domain, still all real numbers. Okay? Now let's look at another example. Okay? This example right here is let's see. Oh, there we go. Okay, this one, what's different about this one? What's different about this one, the most obvious thing that's different, is that this one's pointing down. Okay, so instead of having a minimum, it has a maximum, and that maximum is right here. The value of that maximum is 9. Okay, the vertex that I see right here is 0, 9. Again, as you see, the y part of my vertex is the maximum of my function. Okay, my axis of symmetry is x equals 0 because that's the equation of the y-axis, which is what my parabola is kind of surrounding. Okay, my range is y is greater than, I'm sorry, is it greater than? No, it most certainly is not, because look, all my y values are less than 9 or equal to 9. Okay, so remember, when I have a maximum, and when my parabola is pointing, when it's pointing down, my range is less than. And when it's pointing up, my range is greater than. Okay? Okay, and my domain, no surprise there, all real numbers. Okay? Let's take a look at this next one here. Okay? I have g of x equals f of x minus 5. Okay, so I'm going to take that same original function, this f of x, and I'm going to substitute it in right here. So g of x equals -x squared plus 9 minus 5. Now, based on what I've seen so far, I think it's going to go 5 units down, but I ain't too proud to check in my calculator. So let's put these both in here. Okay, so I'm going to clear these out. I have -x squared plus 9, and then in my second equation I have -x squared plus 9 minus 5. And let's look at the graph. Okay, that looks pretty darn familiar right there. Okay, and there we go. It's shifted down 1, 2, 3, 4, 5. There we go. It shifted down 5 just like I thought it was. So my new vertex, if I take this one here, I can go 1, 2, 3, 4, 5. My new vertex is at 0, 4, which makes my axis of symmetry x equals 0, my range y is less than or equal to 4, and my domain stays all real numbers, okay? So I'm hoping you're kind of starting to see this isn't, it looks kind of crazy, but really it's just substitution, just like the system, solving systems by substitution we just did. It's really just substitution, okay? Let's look at this last one here. And this one is, so all the ones that we've had up until now have like kind of lived on the y-axis, but this one doesn't. So I've been telling you the axis of symmetry isn't always x equals 0. Well, here's a situation where it's actually not, okay? So if I look, I can see right now, there's my vertex. My vertex is at -4, -6. Okay, now we haven't really talked about vertex form, but if you look closely, you may be able to figure out how this relates to vertex form. We're going to talk about vertex form later this week, maybe. I think we're going to talk about it tomorrow, maybe beginning of next week. But we're gonna be all up in vertex form, so don't worry about that. Okay. Do I have a maximum or a minimum? Well, I've got a minimum because I've got a lowest value. The lowest value I see is -6, which matches up with my range because I can't go lower than -6 on my parabola. Okay, my axis of symmetry is x equals -4 because right here at -4, that is the line that goes right down the center of my parabola. My range is y is greater than or equal to -6 because my parabola is pointing up, so all values bigger meet the criteria. And of course, my domain is all real numbers. Okay, now if we look at this one, h of x equals f of x plus 3, again, I'm going to do that same substitution that I did, f of x and f of x. Okay, so h of x equals, holy smokes, equals 1/2 x plus 4 squared minus 6 plus 3. Okay, so again, if we put these in our calculator, we have, oh my goodness, 1/2 x, whoopsie, parentheses, x plus 4, close parentheses, squared, minus 6 plus 3. Boy, well, not plus 3. We're not doing the plus 3 here. I would kill for copy and paste. I'm sure there's a way to do it with my calculator. I haven't figured it out. This might be the time. Okay, alpha y equals, we have 1/2 x plus 4 squared minus 6 plus 3. So this is my original and this is my transformation. And what do we think is going to happen here? Well, I see plus 3. I think we're going to go 3 units up. Okay, so let's look and see if that actually happens. Oh my goodness. This is, oh, there it is. Okay. All right. And yep, that's what happened. There it is. Now, this one's a little harder to count. So I'm going to actually move it. Now, on my worksheet here, it's already moved. I don't like that. So I'm going to actually move it here so we can actually see ourselves moving it. So we have plus 3. So we're going to go 1, 2, 3 and move our vertex 3 up. We have -4, -3, which is the same thing they have here in this one where they've already moved it for us. Okay, so again, as always, my domain is all real numbers. Okay, my axis of symmetry is x equals -4, and my range is y is greater than or equal to -3. Okay, so we're going to continue to do more. We're going to do more transformations tomorrow, and by the time we're done doing all these transformations, we're really going to be able to see what vertex form can do for us. How all the stuff we did earlier in the year with transformations is really kind of like it all comes together in vertex form. I will see y'all tomorrow.